Hello, 6th graders. Welcome to Big Ideas Math, section 10.3, Shapes of Distributions lesson. Pause while you write the section number and title in your math notebook. Pause again while you write today's lesson objective. Today's objective is describe and compare shapes of distributions. Pause while you copy the following key idea into your math notebook. It says you can use dot plots and histograms to identify shapes of distributions. Symmetric and skewed distributions. A distribution is skewed to the left if the tail of the graph extends to the left. Most data are on the right. So if the data is on the right, it's skewed left. If a distribution is symmetric, the left side of the graph is a mirror image of the right side of the graph. And if a distribution is skewed right, the tail of the graph extends to the right and most data are on the left. Take a look at the study tip that is over to the left side here, and it says if all the dots are of a dot plot or bars of a histogram are about the same height, then the distribution is a flat or uniform distribution. A uniform distribution is also symmetric. So be sure you copy that into your notebook as well. Continuing on page 452 with example 1, it says, describing the shapes of distributions. We're asked to describe the shape of each distribution. Let's look at letter A, where we have the daily snowfall amounts. And we have a dot plot. So it says, if we look at the shape of the distribution, we can see that most of the data are on the left, and the tail extends to the right. So the distribution is skewed right. So what you need to remember here is that you're looking at the tail, and the tail goes to the right, so the distribution is skewed to the right. So the data is to the left, the tail is to the right, so the distribution is skewed to the right. Let's look at letter B. We're looking at passes thrown in a football game or a season or something. And it says the left side of the graph is approximately a mirror image. So if you draw a line down the middle of the graph, there we go, it's about half and half. It's not quite exactly a mirror image, but it's pretty close, of the right side of the graph, so the distribution is symmetric. At the bottom of page 452, there is an on your own problem, but we are going to do it together. You need to be sure you write this in your notebook so that you will have an example to follow when you get to your lesson practice. It says describe the shape of the distribution. So if you copy this into your notebook as exactly as you can, be sure you draw the number line and put the title of the graph and put the little legend here that says number of emails, and then draw the dots and then draw a line over it so you can see the shape of it. You will see that the tail of the graph is on the left. So the tail goes to the left. So that means our data is skewed to the left, or our distribution is skewed left. So we're describing the shape of the distribution. It is skewed left. Moving on to page 453, Example 2, we're still describing the shape of a distribution, and here is a frequency table off to the left with ages and frequencies, and it says the frequency table shows the ages of people watching a comedy in a theater. Describe the data in a histogram, or display the data in a histogram. So they did that for us. So lucky us, we don't have to draw that graph. And it says describe the shape of the distribution. It says draw and label the axes. So whenever you do a histogram or any type of graph, you need to have your title. That's the title of the graph, so it says comedy attendance up here. And you need to label the axes, so the ages down at the bottom and the frequency over on the left. So a graph is not complete until you have your numbers on the axes and your labels. So be sure when you are doing your graphs for your test or for any other reason that you have all of those parts of the graph in place. So it says most of the data are on the right. So if you draw a line over it, you can see that most of the data are on the right and the tail extends to the left. So since the tail extends to the left, the distribution is skewed left. Example 3, we're comparing the shapes of distributions. So the histogram shows the ages of people watching an animated movie attendance, or an animated movie in the same theater as in example number 2. So we describe the shape of the distribution. So we look at it here. And most of the data are on the left and the tail extends to the right. So the distribution is skewed right. So which movie has an older audience? So we can see that the intervals in the histogram are the same. So we used the same intervals. The numbers down here on the bottom are the same. And most of the data for the animated movie are on the left. Well, that's because most kids kind of like cartoons more than maybe comedies in a theater. While most of the data for the comedy are on the right. This means that the people watching the comedy are generally older than the people watching the animated movie. So that makes sense. So the comedy has an older audience. At the bottom of page 453 is another on-your-own problem that we are going to do together. What that means by doing it together is not that you sit there and watch it, but that you write this in your notebook, and we do it together so that you have this for reference when you go to do the practice problems. It says the frequency table shows the ages of people watching a historical movie in a theater. It says display the data in a histogram and describe the shape of the distribution. So we are going to do that. I'm going to show you what your histogram should look like, and you need to actually draw your histogram in your notebook. Okay, pause while you make your histogram, and I hope you can make yours a little bit neater than I was able to make mine with my stylus on my iPad. You should have a little bit more luck with your pencil. But this is the basic idea, and after you have had a second or a couple of minutes to make your graph, take a look at it, and if you look, you can see that the data is not all to one side or the other. It is more, if you draw a curve over it, it's more just one big hill in the center. And if you draw a line down the middle, it's kind of a mirror image on both sides. So we can say that this data is symmetric, or the distribution is symmetric. And then, so that took care of part A. And then it says compare the distribution of the data to the distributions in examples 2 and 3, and what can we conclude? So we can say that in examples 2 and 3, the data was skewed left and right in both of those examples, So if we look at the ages, we can see that in this example, our audience is older. So the historical movie has the older audience. And we can say that pretty confidently because when we look at our data from examples 1 and 2, even with the comedy theater, the oldest people there were only 37 years old, and here the center of our data ends at 39, and then it still goes on and beyond to all the way up to 60 to 69 years old. So the historical movie has the older audience. You are almost finished with this flipped lesson. To complete it, you need to be prepared with your notes, vocabulary, and any other work from the flipped lesson completed. You also need to be prepared with any questions and a good attitude.